Good day everyone! For this week machine, nuclear magnetic resonance, we chose to tackle the NMR spectrometer ZETA of JEOL USA Incorporated. I am Destiny Narcamo, reporting with my groupmates Catherine Paitan, Rafaelin Espiritu, and Mohanisa Marwar. And now, we begin! JEOL is a leading global supplier of electron microscopes, ion beam instruments, mass spectrometers, and NMR spectrometers. JEOL instruments are helping to advance scientific research throughout the world. Among the customers are winners of the Nobel Prize, recipients of major research grants, and world-renowned scientists. JEOL customers use their instruments to support discoveries in virology, biological and medical research, drug discovery and genomics, national defense, forensics, failure analysis, nanotechnology, and novel materials. JEOL USA was founded in 1962 as a wholly owned subsidiary of JEOL Limited in Akishima, Japan. And now, NMR spectrometry. For a basic knowledge, an NMR instrument allows the molecular structure of a material to be analyzed by observing and measuring the interaction of nuclear spins when placed in a powerful magnetic field. For JEOL NMR spectroscopy expertise, they have been producing high-performance nuclear magnetic resonance spectrometers for more than 60 years for structural analysis of organic compounds, natural products, protein-drug interactions, and polymers. They have manufactured one of the highest field magnetic fields for NMR in the world. The NMR spectrometer is an indispensable tool for structural determination of molecules, molecular motions, and interactions. JEOL offers a wide range of high-performance NMR spectrometers. They regularly manufacture a wide range of spectrometers. For routine NMR experiment, they offer 400 MHz spectrometers. For expertise requiring more sophisticated measurements, they offer several models at progressively highly field strengths. The FT NMR Spectrometer ZETA JNM ECZR series is a new system that fully incorporates the latest digital and high-frequency technologies, improved reliability, and a more compact size, made possible by incorporating more advanced and integrated circuits. It supports even greater expandability options than current models for multi-channel operation, high-power amplifiers, and other accessories. The bus line for control of attachments has been upgraded to high speed and enables highly accurate and rapid control. This series is regularly offered at 500 MHz, 600 MHz, 700 MHz, and 800 MHz. Even higher field instruments are available. You can inquire by sending email at salesinfo@jeol.com, seen in the slide. It was already on the market by August 2014. The price was still not publicly shown. We are pleased to share this to everyone that JEOL Resonance Incorporated, headed by President Takahiro Anai, has been selected as one of the Global Niche Top Companies Selection 100 in 2020, recognized by the Ministry of Economy, Trade and Industry. JEOL Resonance Incorporated has been selected in the electricity and electronics category for its excellent technologies in nuclear magnetic resonance spectrometer, which have contributed to global scientific technologies and also for its steady sales growth in overseas markets.
Good day everyone! Today, let's discover what are the parts and features of the NMR spectrometer ZETA in the JNM-EZZR series. The JNM-EZZR series has these common parts: the computer, spectrometer, and superconducting magnet. The computer is in charge of the instrument control and data processing, while the spectrometer transmits and receives the radio frequency waves used to make the NMR measurements, and the superconducting magnet generates a powerful magnetic field that is tens of thousands of times stronger than the Earth's magnetic field. Samples are placed within this magnetic field and exposed to radio waves. Spectrometer Control Computer, or the SCC, is a high-performance computer with large capacity hard disk and is used for execution of pulse sequences, signal-to-noise calculation during measurement, storage of data, data processing, and etc. are all possible and independent of the workstation. All measured data is written to the SCC hard disk without fail, thus it is also considered as data server. Even if there is any kind of failure to the workstation computer or network during sequential measurements, all measurements that were submitted will be executed normally and the results will be written to the SCC's disk. Even in a multi-user environment where many users require different measurements and processing, stable operation of the instrument is assured. Multi-sequencer. The sequencer controls RF, lock and PFG channels during pulse sequence execution. The JNM EZZR spectrometer can use multiple slave sequencers, which controls each of these channels, and a master sequencer which synchronizes all slave sequencers. With this, any NMR pulse sequence can be carried out. The JNM EZZR spectrometer can accommodate up to 8 nuclei, 32 frequency sources, and PFG simultaneously. It can compile and execute any complex pulse sequence, even those that may be developed in the future. One of the latest features of the NMR spectrometer ZETA is the STS, or the Smart Transceiver System. It is a transceiver system offering high performance in a compact size using a fusion of integrated digital circuit technology and the latest high-frequency technology. The design is optimized for efficient transceiving and high-precision digital signal processing, which gives rapid and precise control of the radio frequency. The compact unit is equipped with signal receiver and transmitter functions that allows generation of up to 8 independent frequencies and enables event control at 5 nanoseconds resolution. Highly precise digital control. The STS used in the JNM EZZR spectrometer realizes control at the high speed for frequency, phase, and amplitude modulation with a control time resolution of just 5 nanoseconds. The high-speed digital control is extremely useful for high-speed phase modulation pulses, which are required for the most recent NMR pulse sequences. The same time control performance is offered for various external systems. High-performance DDS, or Direct Digital Synthesizer, is a unit of the JNM EZZ spectrometer available from the STS. It can create a very wide offset range, and using an appropriate probe, this enables a pseudo-3 nucleus measurement with a standard instrument. Receiver. The receiver of the JNM EZZ spectrometer is controlled by the sequencer. A reference frequency generated in the receiver can be dynamically modulated for phase and amplitude even during FID sampling. In addition, the digital receiver filter optimized for NMR ensures accurate quantitative results. Multi-sequencer and multi-dimensional NMR measurement. The JNM EZZR spectrometer can control up to 4 RF sources, thus 8 nuclei and 32 frequencies, using the multi-sequencer method, with each RF source controlling 2 nuclei and 8 frequencies. Intelligent control of multiple RF sources enables not only highly precise execution of complex multidimensional NMR measurements, but allows the use of parallel expressions within the pulse sequence. In addition, by using conditional statements within the pulse sentence or sequence, more than one experiment is possible during the same pulse sequence program. Shimming. The gradient shim capability of the JNM EZZ series is not limited to observation of deuterium, as is normally used, but also other nuclei such as 1H or 19F. Such functionality is useful for no-D NMR and can also be used for measurement of solids. Gradient shimming is a high-speed shimming method that measures the magnetic field distribution of the sample, compares it to the standard map, then calculates and applies the required shim values for correction so that the magnetic field map becomes uniform. Digital NMR lock circuit. Application of the STS technology provides high precision and high-speed digital control of the 2H lock. This new digital feedback circuit offers extremely efficient control of the magnetic field against external modulation. The precise digital lock feedback mechanism thus enables highly stable operation for protracted measurements. Highly stable temperature control system. The temperature control system enables stable measurements using a newly designed heater with improved response. The JNM EZZ spectrometer allows faster and more stable operation of peripheral devices using the new high-speed bus control line.
In continuation to the above discussion, the next is head amplifier chassis. You can see that there is a three picture. The first is the head amplifier chassis, the second picture is the indication of reflection dip when probe tuning, and the last is indication of remaining quantity when refilling helium. The head amplifier chassis has various functions related to probe and the superconducting magnet. A touch panel display is located on top of the head amplifier chassis, offering an intuitive user interface. During probe tuning, which you can see on the second picture, the reflection dip and reflection value are indicated, whilst during cryogen refilling, the actual level of cryogen in the magnet is indicated in real time, which is in the third picture. It makes the routine maintenance related to probes and superconducting magnet convenient and efficient. Power amplifier. The power amplifier amplifies the RF or radio frequency pulse and outputs it to the probe. Various models are available depending on the purpose, but all power amplifiers exhibit excellent linearity and response performance. The GNM EZZ spectrometer is designed so that the power amplifier keeps constant thermal stability regardless of output, non-output, or RF pulses. Thus, stable RF output is achieved for every kind of measurement, regardless of number of pulses, pulse width, intervals, etc., used within the pulse sequence. PFG or Pulsed Field Gradient. PFG, controlled by STS or Smart Transceiver System technology, offers technical advantages. STS provides digital high performance comparable to that of oscillation and detection of RF signals. In particular, the EZZ spectrometers allows for lock control with higher precision and better flexibility, provided by a lock feedback mechanism based on digital control technologies. This digital control design enables the EZZ spectrometer to provide magnetic field correction according to the environment of the instrument and samples. The EZZ spectrometer can also use the lock transmitter and receiver system in application measurements. The new PFG control offers high precision and stability for measurements that requires high precise controls such as DOSY, etc. PFG amplifier for the JNM EZZ R series, two models of PVG amplifiers with different power outputs, 10 ampere and 30 ampere, and it depends on the buyer what models of PFG amplifier power outputs they want. Intuitive control software. Incorporating an additional interface for simple routine operation, The ZETA software for spectrometer control and data processing support both simple and sophisticated applications. A minimum sequence of operation is needed for routine, standard analyses such as selection of a solvent or measurement mode. For more complicated analysis with numerous conditions, the system will automatically define hardware parameters, including those for the spectrometer and probe, allowing the operator to set up only the conditions specific to the sample or research objectives. Flexible room layout. Comparing JNM ECZR to JNM ECA2. In JNM ECA2 series, the spectrometer requires a 67% more compact size, while in JNM ECZR, all system units including the magnet and compact auto multi-sample charger can be laid out efficiently in a small room. Installation requirement. The following table is a requirement if you want to install or avail their JNM ECZR. For power supplies required for installation, this composed of spectrometer, data system, air compressor with 400 MHz, air compressor with 500 MHz or higher, backup, and ground resistance. The next is installation room. This includes the temperature range, humidity, ceiling height, and 0.5 MT position. So this is an example of an installation room of 500 MHz, where you can see the setup of every power supply that is required for the installation of JNM ECZR. Recommended room layout may vary depending on the spectrometer configuration and apparatus in the room.
Hi everyone, I am Mohanise Mariwar. In continuation, the JEOL Resonance Incorporation has been awarded the 2016 Goodies and Award for their product, which is the Nuclear Magnetic Resonance Spectrometer ZETA, or the JNM ECZR or ECZS series. As you all know, the Goodies and Award is a comprehensive design promotion system that chooses good design out of a variety of unfolding phenomena. It is hosted by the Japan Institute for Design Promotion, which is a public interest incorporated foundation, and also the submissions come from a wide range of fields, and in every year there are 1,200 designs are being recognized, and the recipients of Good Design Award are granted to use the G symbol as an emblem of good design for over half a century. The Nuclear Magnetic Resonance Spectrometer ZETA is a next-generation system and incorporates the world's highest performance in the smallest chassis that fulfills a wide variety of applications. The spectrometer was reduced in size by 55% and 65% for power consumption compared to previous models. The producer of the product is Hiroto Sumatsu, the director of JEOL Resonance Incorporation. The director is Kenichi Hashitani, Timo Development Group, Engineering Division of JEOL Resonance Incorporation, and the designers are Ken Kiyuki Okuyama, the CEO of Ken Okuyama Design, CO Ltd, and Yuko Murata Mechanical Design Team, Design Group Engineering Division of JEOL Resonance Incorporation. In conclusion, throughout our discussion, the nuclear magnetic resonance or NMR technique is used in quality control and research for the analysis of components such as in a mixture, structure, the nature of substances, and others, and it provides vital contribution to the environment and society, where its applications are for drug discovery, food safety testing, development of new organic materials, fuel cells, and others. Therefore, this product that we have chosen is a good instrument to be used for the analysis of a certain sample, as it provides high general flexibility and potential supports to various applications, and also it has been developed with basic design concepts that supports excellent functionality and high performance.
Solutions for innovation. With a spirit of creativity and research and development, we will continue to challenge the world's foremost technology and contribute to a brighter future for human society.